We have another great comment right here. They're saying, no, use this other way. And I want to say thank you for this comment because it's just another great example of how synthesis has multiple ways usually, at least on paper. Sometimes you get in the lab, it turns out there's only one way. Let's walk through their synthesis right now and let this be an example to you guys. There are many ways to get to the right answer in synthesis on your exam usually, okay? So use your creativity, think a little bit, have a little bit of fun. I know organic chemistry is not fun to you guys, but oh well. So they're saying do a Kucherov hydration of this acetylene right here. Okay, what that gives us is, here I'm gonna draw this, and that is done with H2SO4 in water, and then underneath it is some sort of mercury salt. I think it's Hg2 plus. Not sure on the specifics, and that will give us this right here. That is going to tautomerize into our acetaldehyde. And then they're saying, okay, we're going to reduce this to ethanol with sodium borohydride. So NaBH4, we're going to get ethanol. Okay. And then they're saying do acid catalyzed condensation because we're making a symmetric ether. So that would be this is what the other person said too, 140 degrees C and H2SO4. Okay. Now, this is a great example. One, not only because it's a similar synthetic pathway, but they go on to say in their other comment is, in their opinion, they don't think this is a very efficient method here, like linear catalyst on the hydrogenation of acetylene. And I'm so glad they said this because luckily, when we are doing retrosynthesis or just synthesis on exams, generally, I'm saying generally because I don't have your professor, only you know your professor. Generally, you are given a ton of leeway with how good that synthesis will be because they are testing you conceptually. Do you know conceptually how to get something from this to this, and can you string that all together? You're generally not being graded on what would the yield be of this in a real life lab scenario. But it is also important to remember that you have that great, wonderful privilege, that artistic freedom, I like to say, okay? Because there are a lot of things this person rightfully points out, and I can tell you plenty of examples from when I was doing my PhD. There are so many things that look great on paper, and there's so many reasons why they should work, and so much literature, whatever, that you get to the lab and they just do not work, or they work and the yield is just garbage. So thank you again to this person for pointing out this other synthesis. Now that's our third synthetic route we have for this. Thank you again.